Welcome back to another installment of Math with Medina. Alright, so for section 3.2, we're going to look at is solving equations that have like terms and parentheses. It's going to be really important that we reach back into kind of our toolbox of skills at this point and really focus on that ability to be able to simplify expressions. Because remember that an equation is two expressions set equal to one another, and it's really important that both sides of that equation, the left and the right, are simplified before we try and solve it. So what we're going to do is we're going to first open up here and do a couple practice problems just to practice simplifying expressions again. So what I'd like you to do right now is pause the video, copy down these two expressions, and I want you to go through the process of simplifying both of them. Make sure you pay a special notice to these numbers in front of the parentheses that we need to start first with distributing those. Alright, so go ahead and pause here on your scratch paper, give these two problems a shot. Okay, let's look at these together. And remember that on the practice problems, you're going to make sure these are part of your notes, that even though you may have done them the first time through on scratch paper, that these make it still into your notes. So we start out, and the first thing that we notice here are these parentheses. And it's really important in noticing these parentheses that we want to get rid of those before we can go any further. We can't really combine anything, simplify anything like that till our parentheses are gone. So the first thing we're going to do is we're going to distribute this negative 2. So we'll rewrite the 5 exactly how it is, and then we're going to say negative 2 times x plus, to represent the 3 here, and then we're going to go ahead and multiply negative 2 times 3. So we'll say negative 2 times a positive 3. And now at this point we can see our parentheses disappeared because of distribution, and we're going to go ahead and simplify everything the rest of the way. So we say, okay, 5, and our order of operations would tell us to multiply now. So negative 2 times x would be negative 2x, and plus, and negative 2 times 3 would be a negative 6. So notice I kept those in parentheses to show that's where they came from. And then at this point we say, okay, what goes together? And I can see that there's a 5 and a negative 6 as a constant. So I'm going to go ahead and rewrite my expression. And it's really important, and some folks have had some trouble with this so far this year, it's really important you remember that this negative sign belongs to the 2x. So we have to rewrite that together, negative 2x, and then we rewrite plus 5. And since we don't need plus negative 6, we can just write that as subtract 6. And then our very last step here, we're going to combine any like terms, and we have these two sets of like terms. 5 take away 6 would leave us with negative 1. Alright, so we simplified the first one. Alright, and so for the next problem, again, remember we need to notice these parentheses first thing. So we want to get rid of those. So we're going to go ahead and distribute the 2 times the 4. And then we're going to distribute the 2 times the negative 3x. Now at this point, since 2 is positive, another technique different from the previous one is I could write positive 2 to represent what I'm distributing. And what's really important again is that that negative sign belongs to the 3x, so it would be negative 3x plus 8x. So we have our equal sign, and remember the equal sign just says, okay, on to the next step. So on to the next step, we are going to just multiply everything out in the order of operations. So 2 times 4, and positive 2 times negative 3x would be negative 6x plus 8x. So now at this point, I can see pretty clearly I have 2 like terms here. And we have the option of rewriting things or just combining them as they are. The only mistake that consistently we've been running into with simplifying expressions is when folks combine terms like these, they tend to add the 6x and the 8x, then put the sign back in. But if you watch here, if I were to rewrite it, since 8x is bigger and it's positive, I'm going to write that first, minus 6x plus 8. And remember, that's just a commutative property. I can rewrite each one of my terms as long as I remind myself that it stays true to the original term it started with. So if you look, I took each of those pieces and I have the 8x, I have the negative 6x, and I have the positive 8. So then at this point we can just combine our like terms, and we have 8x take away 6x would give us 2x plus 8. So that would be our simplified expression, and again the way we know it's simplified is we have our variable term and we have our constant term, and there's no way mathematically at this point to put those together unless we know what x is. Okay, so those That skill is going to be really important that we have that. So make sure as you're looking over this that you really understand this process, and please, if you don't, come and speak with me as soon as possible, because this is something we need to understand very well. All right, so let's look at one of our first 3 example problems together. So the problem is negative 21 equals 7 times the quantity 3 minus x. So again, we notice straight away there's these parentheses we need to get rid of, and we also have our kind of reminder in the back of our head that there's 2 sides to our equation. So if we think about things from left to right, well, negative 21, that's simplified. So I can go ahead and just rewrite that. And then on the right-hand side of things, I'm going to distribute 3 times 7 times 3, and then I'm going to distribute 7 times a negative x. And remember, that negative sign belongs to the x, and one way you can even remind yourself of that is you could do something like this, where you can see visually, I'm just showing you that you can see that that negative belongs to the x. So from here, we say, okay, negative 21, because again, this left side of things is already simplified. The right-hand side, we have 21, and positive 7 times negative x would be a negative 7x, because remember kind of in the back of your head that there's a 1 there, so there's 1x. And then from here, we want to isolate that variable term. So I'm going to get rid of 21. And negative 21, take away 21 more, is not 0. Remember, it's negative 42, because they have the same sign, so they stay negative. Then I just add the 21s together, and these ones cancel out, and we're left with negative 7x. Final step in things, we divide by negative 7, and I'm left very clearly with 6 equals x, or I know some people prefer with the commutative property, I can rewrite it and call it x equals 6. Don't forget to put a box around your answer. And whenever we get a solution, it's really important that we find our proof. So I bring out my super P's. Remember, that's our symbol from here on out. And negative 21 equals 7 times 3 minus x. Now, it is super important, and this is a mistake I already have been noticing in some of the homework. It's really important that from here you don't distribute and you don't combine anything. You don't put together like terms. That you immediately on a proof substitute in the value for the variable right now. So we substituted that in, negative 21, 7 times the quantity 3 minus 6. And order of operations tells us I need to first put together what's in the parentheses. 3 take away 6 would be negative 3. I rewrite everything else, so negative 21 equals 7 times negative 3. Negative 21 equals, and 7 times negative 3 is in fact negative 21. Alright, so we can see that one, we're good to go, it is correct. But again, I cannot stress 2 things to you enough. The first one, make sure that you get rid of your parentheses. And the second one, it's really important that you substitute in for that variable immediately on the very first step of showing your proof. Alright, so 2 more problems to go. Stick with me. Example 2. We start out, I can see straight away that there's parentheses again I'm going to need to get rid of. I also notice that my x is in those parentheses. So for some of us to see it a little better, I went through, made it nice and colorful for us, and there's a reminder again that that negative sign belongs to the 4x. So we start out, and just for those of us at home that like to have our line dividing our equation in half, there we go. So now we start out here and we say, okay, I'm going to distribute negative 3 times a positive 8. I'm going to distribute negative 3 times a negative 4x. Please, please, please make sure that that negative sign sticks with that term. Negative 3 times 8 is negative 24. Negative 3 times a negative 4 is positive 12x equals 12. And then from here I can see here's my variable term I need to get by itself. So I'm going to add 24 to both sides. And then I'm left on the left-hand side with 12x equals, and on the right-hand side, 36. And then from there, remember, we need to get x alone. So remind ourselves, 12x, it means 12 times x. So the inverse of multiplication is division. And you can see we wrap up here with x equals, and 36 divided by 12 would give us 3. So it's time to bring out our super P again, and let's do a proof. So recopy down the original problem, exactly how it is. And you're going to see why it's super important. Every detail is perfect, because the very next step, just like I said before, we're going to substitute in that value. Now, this is where the equation doesn't change, but notice I turned my parentheses to brackets. And the reason I did is because for here, in place of x, I need to substitute in 3. So it's important that we can see where that belonged to, and I always like to put parentheses around my substitutions. So then from here, I go through in the order of operations. I go inside the grouping symbol or inside the brackets, and I simplify first the multiplication. So 8 minus 4 times 3 would be 12. And I still have brackets or a grouping symbol to get rid of, so I need to do 8 minus 12, which would be negative 4. So now I have negative 3 times negative 4. Negative times a negative is a positive, so we get 12 equals 12. All right, so this third problem here, what I want you to do right now is go ahead, pause the video, and I want you to try this one on your own. So pause it right here. All right, so let's take a quick look at this together. First things first, we should notice pretty clearly there's some parentheses to get rid of, so I'm going to need to distribute right in front of what's in front of it. And just again, for those of us at home that like to have the line, it's not necessary, but it kind of helps us see that there is a left side and that there's a right side to our equation. So when we talk about the left and right of our equation, we know it means on both sides, either side of the equal sign, depending. All right, so again, just so it kind of stands out for some of us at home, here is everything a little color-coded. You can see there's 2 x's this time around. So after we distribute, we're going to actually look at needing to kind of put the x's together before we can solve. So we start out and we say, okay, negative 2 times a positive x, and negative 2 times a negative 1. I rewrite the 5x out front, and I rewrite the 8. Because that right-hand side of things, totally simplified. There's nothing we need to do over there. All right, so from here now we just simplify our expressions. So we say 5x, that's simplified. Negative 2 times x would be negative 2x. Negative 2 times a negative 1 would be a positive 2 equals 8. And so from here, if I look at this expression, I can see that there still are 2 like terms that need to go together. So before I can move anything over to the right, or I can isolate the variable, which means get it by itself, I need to combine my like terms. So 5x take away 2x would give me 3x plus 2 equals 8. And then from there, I can remind myself it's really important we get this variable term alone. So I have to get rid of the constant. So I'm going to say take away 2 on both sides, and what I'm left with is 3x equals 6. And then from there, most of us can notice we need to get rid of the 3, and remember the 3 is multiplying times the x, so we divide by 3 on both sides, and I'm left with x equals 2. Time for one last proof. Recopy our equation, 5x minus 2 times x minus 1 equals 8. And again, this is where it's super crucial that you substitute immediately for the variable. So we say 5 times, and my answer this time around was 2 for x, my solution. So then we say minus 2 times the quantity, and we just said that our solution was 2. And lastly, take away 1 equals 8. So now we go through the order of operations. And first I would do my parentheses. So we'll say 5 times 2 minus 2 times 1, because 2 take away 1 would be 1. And then multiplication from left to right, 5 times 2 would be 10, minus 2 times 1 would be 2, equals 8. And 10 take away 2 equals 8 equals 8. Whew! All right, so I know this video is a little bit longer, but I really think that this is where we take a number of skills we've been developing with solving with inverse operations, simplifying expressions, keeping our equations balanced on both sides, and we kind of put it all together. So I'd really emphasize to you, please make sure that you understand the 3 problems in this video. That means you need to watch it a 3rd time, please do. I look forward to seeing you in class tomorrow. And again, if there's any struggles you're having when it comes to understanding this first step here, or most of all, understanding how to simplify an expression, please come see me at lunch. Come let me know before class so we can get some extra worksheets and really continue to develop this idea. All right, I look forward to seeing you tomorrow. Have a wonderful evening.